In order to protect yourself, you got to know what attacks may come your way. Stay tuned to learn about common attack methods.
You're watching IT Pro TV.
I'm glad you could make it back for more GSEC. We're going to be talking about common attack methods, and I know one near and dear to my heart is injection attacks, right? Is that on the list of our common attack methods?
I'm going to put that at the top of the list because I love it so much myself, just because, well, once you start messing with injection attacks, you really find it, all the other types of attacks can be just a little bit displeasing. It's not as good of a fruit. What do we mean by injection attacks? Basically, I can do things like code injection, where I'm actually able to inject snippets of code into an application, and it will, hey, this is a fun idea. It will run that. Not a great thing to have happen to you if you are on the defending side of things. You also have command injection, where it's like, hey, here's a command I would love for you to run. Why don't you do that? And it goes, hey, anything you need because I'm here for you. And it runs your commands. Again, not great if you are a defender. You also have things like SQL injection, where I guess it's just kind of a subset of code injection, because SQL is technically a type of language. So you're injecting SQL, transact SQL commands and language into the application. It's interpreting them, running them for you, and giving you those results back out. I can actually give you a couple of examples of this. And let's take a look really quickly. Jump into the computer. I've got this DVWA device here. It's looking a little peckish. There we go. Has a pinging device. You've probably seen this in another one of our episodes. I built a one-off of this type of thing. And I can just put in whatever I like and then do just like we did before, ls. And you'll see that it not only runs the ping command against 0.0.0.0, but it also runs ls, and there's the output of it right there. Comes right back out inside of this web application. Very, very nasty stuff if you get that kind of execution. For SQL injection, I'll jump over to this tab. Looking for a user ID, so I can stick like 1 in there or 2. But once I start playing around with it, maybe I put in a semicolon, hit submit, and you'll notice I'm getting an error. It kind of lets me know that I've injected SQL into this application. From there, I can kind of just start playing around with what SQL it will accept. Maybe from there, I do a good old-fashioned or 1 equals 1. It submits. Notice I'm still getting an error there. I might need to do something like an inline comment code to tell it anything after this. Once you've processed this, don't do anything else, right? So I think with this particular database, I will need a hashtag like that. Hit submit, yes. And now you're seeing it's executing my SQL code along with the code that's on the back end of this application. So very, very nasty. I could probably leverage, if not all of these, to some sort of access to the machine, maybe like a reverse shell, start to read and write files. Could be very, very bad day. This is why, Justin, I agree with you that injection attacks, they're pretty nice.
And you've noticed that there's a bunch of information I've just gathered, right? From SQL injection or even command execution might get reverse shells, can find additional information. But sometimes people just like to watch the world burn, and they'll use those for, I know for me, I see like regex, DOS, denial of service type things. I can inject a regex. It does like a weird exponential blow up. But that's not the only way that denial of service can occur, right?
No, it's just one really good example, actually. It's just we've got some resources and we want to utilize them all. So we either have like a denial of service, or we could also move into what's called a distributed denial of service, which is a type of denial of service attack. So with any denial of service, it goes right back to the idea of utilizing all the resources that you possibly can. Maybe it's a specific resource you're going at, or all of the types of resources that are available from a given system. But whatever you're trying to do, as long as you can saturate that so that it can no longer process requests from end users, well, it basically becomes a brick that does nothing, right? Because it's too busy. It's so busy, in fact, that anybody that asks it to do something, it cannot reply. So that would be like a traditional denial of service. Maybe I eat up all the RAM, or maybe I eat up all the network bandwidth, something to that effect. I give it some logic that's going to blow up on it, and now the processor's just way too busy to help, right? With a distributed denial of service attack, though, I want to be able to differentiate. That's where I have multiple players or attackers. Maybe it's one attacker with a botnet, or it's just a group of people like the Hacking Group Anonymous. They've decided, hey, on Thursday at 2 p.m., we're going after such and such entity, okay? And then everybody starts hammering it. A couple of tools that come off the top of my head, like low orbit ion cannon or high orbit ion cannon, those were used in those types of attacks, where you can just hammer web servers with web requests and utilize all that. You can do amplified attacks and reflected attacks, all sorts of crazy stuff can go on there. So denial of service is something you want to get your mind wrapped around, but the basics of it is going to be that we're going to utilize all those resources in some way, shape, or form so that the device is too busy to answer legitimate requests.
And that's one of the things where I always think about, if you called everybody you knew and they called everybody they knew and you all showed up at the same fast food restaurant and ordered at the same time, things are just going to shut down. But you actually talked about a weird experience for end users, right? That kind of just locks things up. I'm not going to get my hamburger. I can't log in. But then I started thinking, wait a minute, end users. They end up being this interesting vector of like attacks as well. And probably the first thing is passwords, right?
Passwords, right? We have discussed passwords in the past. This is, that's a lot of P words going on in one sentence. It's a lot of fun to do, but that's exactly right. Passwords tend to be the weak link. A lot of times people use insecure types of passwords. And not only that, but insecure passwords tend to be common among a group of people. So when we talked about passwords before, we talked about how to create a secure password. But if I'm allowing my users to create insecure passwords, it's a very good probability that multiple users will create the same bad password. And then I can use something like password spraying, which is where I just take a group of known users for any given entity or a system, and I throw at all of those probably a smaller list of very commonly used passwords, and maybe I'll be able to get access through that, because the odds are that somebody's using a bad password in that organization. The more users I have, the bigger pool I have to pull from, and I'll be able to do that. You can also brute force passwords using things like Hydra or Encrack or Medusa. These tools will allow you to brute force against services such as FTP, Telnet, SSH, RDP, any of those network services that we take for granted on a day-to-day basis. So if you wanted to utilize that, you could. If it's a web application, I can also brute force there. And we can even see that information if we're on the same network, and we'll take a look at that in just a little bit. But yes, passwords can be a super weak link, so we have to be making sure that our users are employing good password methodologies.
And regardless of your training, there will be a weak user. I used to work at a place where I was like, yeah, we got strong passwords. Look, they're on the bottom of this keyboard. That's amazing. That's a long password, but I can read it. I can just take it with me.
I'll just write that down, and then they don't even know I took it.
And
right?
It's unfortunate people are going to do that, right? Now, that one's pretty straightforward. I see how that goes, but there's some other kind of nefarious, a little more hidden kind of things that may affect end users, maybe not.
Yeah.
Like a man in the middle.
Yeah, man-in-the-middle attacks, also very common types of attacks where you have an attacker who sits in the middle of a conversation between two endpoints. So maybe I've got a server and I've got a client over here, and I want to pass information. Maybe I'm reading a file, or maybe I'm inputting something or uploading something. Doesn't matter, whatever it is. If I can be the go-between, if I can inject myself as someone who's passing that baton between those two end devices, then I can be able to look in that information. I might be able to modify it. One of the most common ways in which this is done through an ARP cache poison attack, or ARP spoofing, you might hear it as. And what we're doing is we're basically taking advantage of the fact that the ARP tables of most machines update dynamically. That means when a machine reaches out and says, hey, my MAC address is this, well, that end user goes, or the machine does, says, oh, that's great. I'll put it in my table. I'll just update it. I won't bother my end user with it. I'll just do it for them so that we don't have to continually look that stuff up, keep it in the table. But if I use a tool like EtterCap, I can poison that by continually hammering it with information that is wrong and say, hey, no, this MAC address goes with this IP, not that one. And I'll make it so where I'm the one that receives that data. And I can do it for both of those devices so that I can do that very thing where I sit in the middle, look at or modify that information, and then pass it on to each so that no one is any the wiser. Once I have it, well, the game is kind of over at that point. I've got sensitive information most likely, and now I can do whatever I like with it, post it on Pastebin or sell it to the highest bidder on the dark web, whatever hits my fancy. God help us if that happens to you.
And this is one of the things that always concerns me whenever I'm in like a public space or like an airport or something. I go, wait a minute, am I really connecting to an appropriate Wi-Fi? Is it secure?
Yeah.
I tend just to err on the side of caution, and if I do any browsing, I'm reading Reddit or something dumb.
Paranoia pays in this business.
Now, with that said, it does make me really nervous, but I think we got to circle back to those end users because I was just thinking of this time. My mom, she goes, hey, so I just got an email from Microsoft. They said my password has been compromised. I need to change it. I typed in my username and password, and she was like, and then I started thinking, should I have done that?
It just died inside.
And I was like, you need to go change it immediately. She had been phished. And there's many ways that phishing can manifest, right?
Plenty of different ways in which phishing can be seen out there in the wild. That is a very common way. These scammers, they'll call you nowadays. I mean, that's just right there. The fact that you'll ring my number and try to get me. And of course, they prey on the people that don't understand these types of things more often than not. But every now and then they get a person like you or me who is interested in being more secure, but not all the time. So what does that look like? It looks like, hey, I work for Microsoft. I don't actually work for Microsoft. And there's something wrong with your account. There's nothing wrong with your account. And hey, why don't you go ahead and click this link, log into your account, and verify that there's nothing wrong with it, because there's nothing wrong with your account, but I want to get those usernames and creds, so go ahead and do that thing. That's basically what we're looking at. I actually just like really quickly whipped up a phishing type email. So we're all just making sure we're on the same page when it comes to what this kind of thing looks like. So here we go. I just opened a Word document and created this. So there you go. I've just grabbed PayPal, and this is an automated message. Typical things that you're going to see inside of a phishing type of email, right? Warning, your PayPal account has been limited. Oh no, what do you mean? Your account, oh, that's weird. Your account has been limited in order to protect it and will continue to be limited until you verify suspicious account activity. Please log in to your PayPal account and accept funds trying to be sent to you. Okay, well, I want funds that are trying to be sent to me, and I don't want my PayPal account to be messed up. Cool, I can click this link right here, and I'm off to the races. I'll get logged in, check out, make sure everything's fine. But what's really happening is they're probably stealing usernames and credentials, or then they're going to log in to your PayPal account, transfer a bunch of money, use you as a money mule, something to that effect. So we really have to look out for these. You can also get a little more focused with something like a spear phishing campaign, which means I'm going to target, as the attacker, I'm going to target an organization. Or it can even go even more pointed and target like a CEO, and they call that whaling, right? They're the big whale. I want to get that account. They're going to be the key to the entire thing. I'm going to have as much access as I can possibly get. So spear phishing and whaling, subsets of phishing in general, but that's exactly what we're looking at. It's basically a social engineering campaign used through a digital media of some sort, or a phone call. Could be face-to-face, but typically they want you to click one of those links or download something. Next thing you know, you're all messed up, and it's no good for anyone.
And what's interesting is when people read those emails, a lot of times they do have typos, weird spellings, and I read an article where that's to overcome like filtering in some capacities. Like it looks like it came from a legit person instead of like automated mess, even though it says automated in there.
Even though it says automated.
And then there's also the psychological part where maybe not as technically savvy users go, oh, this is someone like trying to help me out. And they just become very trusting. Speaking of trust, whenever you're hanging out, right?
Trust fall. Right
Daniel and I will be talking about things, and I kind of assume that no one's listening, but there is a type of attack where people just kind of, hey, what you talking about over there, right?
Yeah, the old shoulder surf, probably more technically known as eavesdropping. I want to look into the conversation that you're having, take a look at that. We discussed that a little bit in Man in the Middle, right? With Man in the Middle, that's exactly what we were doing. We were eavesdropping, but we were doing it in a very active way. Where eavesdropping typically just means that I'm kind of listening in on the wire and seeing what's going on. Justin alluded to this as well when he talked about going to free public Wi-Fi. When you're connected to a lot of wireless systems, a lot of times that can be a very open platform, right? That's almost like connecting to an old hub back in the day where all that information that's being sent and received is hitting your device, but your device is making the decision whether or not to accept or receive it, right? Because, oh, well, that traffic's not for me, so I'll just drop that. Oh, that traffic's not, oh, there's something for me, great. And it makes that decision based off of the data packets that are coming its way. But if it is hitting my device, Can I see it? Well, yes, you can. You can use things like packet sniffers to look into the packets themselves and see what information is actually there. Let's jump back into my computer here. I ran a Wireshark thing. If you got this, like, let's use this brute force where I was able to like type in admin and password, and then it logs in, right? It says, welcome to the protected password protected area. But when I ran my Wireshark capture, which looks like this, you might be going, whoa, that's a lot of craziness. But I'm just looking for that specific conversation. Once I find it, I can right click, hit follow, TCP stream, and I'm starting to see the data that was inside of those packets. And if I look really closely, I can see things like username admin, password. So I'm eavesdropping. There's no encryption on this, so it's all in clear text. I could do this with FTP. I could do this with Telnet. Anything that sends information in clear text, it's a very good possibility that I would be able to eavesdrop on that conversation, pick up sensitive information from it, and utilize that as an attacker to my advantage. So we always want to be careful with things of that nature, but be aware that it is happening so that we can properly defend as we get down the road. So that would be a very simplistic form of eavesdropping.
I tell you what, Daniel, whenever I see some of these attacks, I just go, man, I am nervous. But luckily, I'm using a Mac, so I don't have to worry about like malware or viruses or anything, right?
Yeah, that's called a big old lie.
Oh.
And it is perpetuated quite often. I've worked with pen testers who have shown me, like, I can generate a malware package right now that works on up-to-date Mac OS. So just because you're running something like Mac OS does not leave you out of the sphere of malware. Malware touches everything. We're talking about mobile devices, we're talking Windows devices, we're talking Linux, we're talking Mac OS, and probably everything else that you can think of that's some sort of edge case operating system that you're messing around with. So we do have to be on the lookout for malware. Malware is basically going to be things like viruses. They're going to be Trojans, programs that look legitimate but have insidious types of programs running under the hood, giving people maybe backdoor access. That's a common one. You also have worms, which are self-propagating viruses. They don't need any human activity to make them go. You should just turn the key, and once it's running, you send it on its way, and it starts propagating itself. So you also have malvertisements, where there's malware inside of advertisements as you go to different websites. You have adware, spyware, all sorts of horrible, crazy things that live out there on the internet. So we have to know to protect ourselves against those things with via our browsers, via our email clients, anything that's going to connect out into that internet. We got to be wary when we are allowing information to come back this way. We could be smuggling in some sort of malware, and that is definitely something we need to be on the lookout for. So can do a lot of hinky damage to your PC, or just give an attacker, which is typically what it's used for, some command and control on the back end so that they can use it as part of a botnet, something to that effect. So you got to be on the lookout for that malware. It's bad stuff.
You know what I love about these episodes, Daniel?
What's that?
Just when I thought my paranoia couldn't get turned up anymore, I just go, nope, it could. I'm now scared, because we've talked about some common attack ones.
Yeah.
We haven't talked about everything, though, have we?
Oh, no. This is by no means a laundry list. And by the way, you got about 6 rolls of the tinfoil behind you there. So
yeah.
We've really cranked up old Justin's meter there. But yeah, this is just common ways. Definitely not an exhaustive list. Plenty of other things that you need to be on the lookout for. Buffer overflows, remote code execution, you name it. Plenty of stuff. So do your due diligence. Learn about all these common attacks so that you can prepare for that exam.
Speaking of due diligence, it's probably best if we know how to mitigate against some of these more common things, but
Could be.
I'm looking at the clock. It looks like we're out of time to do that, so you're going to have to join us back for the next one to see, how do I fix all this crazy stuff? But for now, we're going to go ahead and get out of here. So signing off for IT Pro TV, I've been your host, Justin Dennison.
I'm Daniel Lowry.
And we'll see you next time.
Thank you for watching IT Pro TV.